This is the Unit 6 Math 2 and Honors Math 2 final review. So we left off here on number 33. We have two triangles that are similar. We need to complete the statements matching corresponding parts or finishing proportions. So I know F and I are alternate interior, so that tells me F and I, the angles will be congruent. J and H are also alternate interior because of the parallel lines, so J is congruent to H. And then HGI, that angle is congruent to JGF because they are vertical angles. Now when it comes to writing the proportions, what helps is I've kind of already marked the angles, so that will help me. FJ was the parallel side, so that is corresponding to IH. What I also did there was say F was the single angle marking, J was the double, and I can match them that way. Next one is what matches to GH. Well, GH is the 3 to 2, so 3 to 2, that's going to be GJ. And now FG was 1 to 3, I to G would complete that one. That is because corresponding sides are proportional. When they're similar, corresponding angles are congruent. FGJ went 1, 3, 2. 1, 3, 2 is IGH. HIG is 2, 1, 3. 2, 1, 3 is JFG. Now I'm going to solve a proportion for 34. You have to remember small triangle, big triangle. The small triangle has X and 15. The big triangle has 8 and 18. Not the 3. The total for this bottom side we have to pay attention to is being 18. So it's X over 8 equals 15 over 18. Now I would recommend reducing if you want. You can always do cross product if you didn't want to, but 15 over 18 is going to reduce to be 5/6. Now when I do cross product, I get 6x equals 40. X equals 40 over 6, which is 20 over 3. Fraction is usually good. If it wants the decimal, that is about 6 2/3, or about 6.7 repeating, or 6.6, and that's repeating. 6.7 if we round in the nearest tenth. Fraction is usually good, 20 over 3. Now, three-ways triangles can be proven similar. We have side, 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 meaning all the corresponding sides are proportional. We have angle, angle, meaning you have two sets of corresponding angles that are congruent. You don't need the third because the third automatically is included if the two work by the third angle theorem, but angle, angle works. And side, angle, side is the combination of the two. You need to have the two sets of sides that are proportional, and you need to have the angle that is included between them being congruent. So a mix of the two. Now 36, we need to choose the equivalent expressions. What I like to do on these is I want to write out a cross product and see what else matches. Because really we know they're the same when their cross products match. So here we look. This was what my original proportion turned into. This matches, so A works. This one does not because it's 5y plus 3, where that one was 7. Looking here, the C matches. Now this one, it looks like they distributed. 5x equals 7y plus 21 is what I'd get up on the top if I distributed. So that looks pretty good as well. For number 37, we're going to go small triangle, big triangle, because I have 8 as the length of the total side. So 2 is this side. 2 to the whole side, 8, equals x over 12. This is also 1/4 equals x over 12. By cross product, I get 12 equals 4x and x equals 3. For 38, I'm going to be completing the proof. I was given two sets of parallel lines, that's ABCD, BCDG. Next they said that angle A and DCG are congruent, and then angle G is congruent to what I would think it would be this one here, so they match, that would be BCA. Now the reason those two sets of angles are congruent, in the past so far we've talked about parallel lines lead to alternate interior. This is not alternate interior. This is because they are corresponding angles are congruent. So because the lines are parallel, corresponding angles are congruent. An example to that would be if I had those two angles in parallel lines, we call those corresponding, that's the angle pair we have. Last line, well, I have two sets of angles, so this is going to be an angle-angle solution, and I'm going to say triangle ABC is similar to triangle CDG.